The history of physics is a search for a single set of rules, one mathematical language that describes every scale of the universe, from the movement of galaxies to the vibration of atoms. On the subatomic level, quantum mechanics provides a reliable map of particle behavior, governed by probability and uncertainty. On the cosmic level, general relativity explains the smooth curvature of spacetime, dictating how gravity shapes the stars. But when these two frameworks are applied to the same event, the math produces contradictions. The equations generate infinities, signaling a deep inconsistency in our understanding of nature. For a century, these pillars of science have remained isolated, leaving a gap where a unified theory should exist. Modern science began with the assumption that reality exists as an objective external stage, maintaining its properties regardless of whether it is measured. Calculations that ignore the observer's role are the specific source of the paradoxes found in quantum gravity and wave-particle duality. The observer-dependent theory of everything, or ODTOE, addresses this by centering on one axiom: the observer constitutes the observed. Every empirical statement is indexed to an observer with a specific degree of cognitive coherence, making the where and who of a measurement part of the data itself. This observer index provides the necessary coordinate to reconcile the conflicting frameworks of modern physics into a single consistent system. The framework is defined by the relation R equals O hat of psi. This equation describes the formal production of reality. Psi represents the unobserved state. It is the mathematical representation of the universe's pre-configured potential before any measurement occurs. The O hat is the operator. This represents the specific act of observation, the physical mechanism that interacts with that potential state. R is the resulting configuration. It is the physical reality produced when the operator resolves the potential state into a defined measurement. This process requires an observer, a coherence-bearing entity, such as a human, a digital instrument, or an AI, to apply the operator. Without all three components, the state, the operator, and the observer, the system remains a theoretical abstraction rather than a physical reality. In this framework, reality is an active configuration generated by this continuous interaction between the observer and the state. When two different observers interact, the stability of their shared reality depends on the strength of their internal coherence. ODTOE treats belief as a measurable physical quantity, using data-driven inputs to track the structural integrity of an observer's perspective. This is the cognitive coherence formula. It translates psychological and physiological states into a single numerical value. Attentional focus, or F, is quantified through sustained neural firing patterns, while emotional coherence, E, is derived from physiological alignment, such as heart rate variability. Sigma measures the lack of internal contradiction in an observer's dataset, while lambda tracks the frequency of empirical reinforcement, how often their observations are confirmed by the environment. Combining these inputs produces a stability coefficient. This number allows researchers to predict how well an observer's reality will hold up during a physical interaction. By operationalizing these variables, the formula provides a bridge between subjective experience and rigorous physical measurement. Consider the quantum measurement problem. What we call wave function collapse is the resolution of a potential state by an observer's operator. The math of ODTOE describes this collapse as the point where the unobserved potential, psi, meets the finite capacity of the observer, O hat. This same logic applies to the direction of time. Thermodynamic entropy increases because it follows a coherence gradient. Observers with lower coherence levels perceive higher entropy, meaning the arrow of time is a measurement of the observer's interaction with the state. Indexing the observer provides the finite bounds required to prevent mathematical infinities, allowing quantum mechanics and general relativity to be mapped as configurations in a single space. This perspective places the observer at the center of the physical process. Existence is a measurable construction, driven by the cognitive coherence of those who participate in it. ODTOE offers a unified framework where the act of observation is the mechanism that defines the laws of the universe.